Assalamualaikum. Okay, hari ni kita akan bincang tentang assignment fluid mechanics bertajuk pressure in pipe. Lepas kan hari tu kita dah buat tu kan, eksperimen tu kan. So yang ni lepas eksperimen tu, kalau kau boleh tengoklah slide ni sebab kita dah kumpul kan kita punya kalau korang ada rasa nak tambah apa kat slide ni boleh lah. Equipment ni nanti aku rasa aku nak bagi Amirul kot. Kau cakap equipment, aku akan buat equipment dengan calculation. Kau cakap equipment dengan calculation lah kat kau. Sebab
Good morning everyone. My name is Muhammad Ekmal bin Saleh from class 2B MMMS 101. Today my group will discuss about our assignment in fluid mechanics, which is the pressure in pipe. So this is my teammates. I will start with the introduction. Fertigation is one way of growing vegetables with advantage of minimizing amount of watering. Two types of pipes configurations may be applicable for the watering process is namely straight line or closed. These two different configurations will give variation in terms of flow rate as well as the volume of water received by each plant. The next is objective. Our objective from this experiment is to perform experimental and simulation flow exercise in hose pipe. Second is to analyze pressure variations in hose pipe over a specific pipe length with two different configurations. And lastly is report the findings in an approach. So I will pass to my teammates.
Assalamualaikum warahmatullahi wabarakatuh. And my name is Muhammad Amirul bin Samzuri. My number metric is B09201015. So for this project of pressure pipe, we need some equipment to run this project, such as 3 or 5 mm diameter single connector, 60 mm T connector, 60 mm times 10 meter hose pipe, 5 or 10 mm measurement cup or 10 liter measurement tank, next hose clip, and lastly stopwatch. So based on figure 1, we need to measure maximum flow rate and velocity, then continue to measure maximum height water, and lastly calculate maximum pressure in pipe based on Bernoulli equation. So after we run the experiment, we need to collect the data, and the data is the water collected is 52 millimeter. The time taken is 40 seconds, and the pipe diameter is 16 millimeter. So to calculate the flow rate, we use the formula volume over time. So for the volume, we get 50 meter, but we need to convert to meter per cube. So after the convert, we get 5.2 times 10 power negative 5 meter cube. So we divide the volume with 40 seconds, and then we get the flow rate is 1.3 exponent negative 6 meter cube per second. For the velocity, we use the formula flow rate over area. So the flow rate we get from the previous calculation, which is 1.3 exponent negative 6 meter cube per second, divided by pi over 4 times 16 millimeter millimeter square. So the answer is 6.46757 exponential 3 meter per second. So for the measure the height achievable water jet, we need to use the formula velocity square over rho g plus h equal to pressure. So we just use any number to get the pressure. So my team just use we assume that the height is 1 meter. So the pressure that we get is 1 Pascal. So we assume the pressure is constant to get the height. So use same the formula previous, but for this we just include the pressure is 1 Pascal. Then we get the height is 1 meter. So for the pressure implied, we need to use Bernoulli equation. So the Bernoulli equation is pressure 1 over density plus velocity 1 square over 2 plus gravitational times z1 equal to pressure 2 over density plus velocity 2 square over 2 plus gravitational times z2. So from the experiment, we just cancel the z1 and pressure 2 over density, and also v2 velocity 2 square over 2. So the last equation is pressure over density plus velocity 1 square over 2 equal to gh. So we just include all the measurement that we get into the equation, and we get the pressure is 9.78 kilopascals. Next, for the experiment 2A, which is straight line water hose configuration, we get the water collected is 42 millimeter and time taken is 34 seconds, and diameter pipe is constant, which is 60 millimeter. So same as the figure 1, we need to calculate the flow rate and velocity. So for the flow rate, we just volume over time, so we get the 1.2353 exponent -6 meter cube per second, while the velocity we get is 6.1435 exponent meter per second. And lastly, for the to be closed loop water hose configuration. So for this, we get the water collected is 32 millimeter and the taken is 28 seconds. So the flow rate that we get is 1.1429 exponent 6 meter cube per second, and the velocity is 5.6843 exponent negative 3 meter per second. So that's all from me. Thank you.
Assalamualaikum and hi everyone. My name is Muhammad Haikal bin Amran, Mometric bill 09201037. I will explain about experiment about pressure in pipe. Okay, in my teammate have been present about calculation, and we get the task 1 flow rate is 1.1429 meter cube per second, and then velocity we get 6.465 times 10 negative 3 meter per second. Next, task 2A, we get 42 milliliter of water in 34 seconds. Task 2B, we get 32 milliliter per collected water and 33 seconds in time. Okay, in simulation L pipe, we get pressure inlet 358 to 3.54 Pascal, and pressure outlet we don't have any result, 0 Pascal. Okay, density in the inlet we get 998.2 kilogram per meter, and density outlet we get 998.2 kilogram per meter. Mesh, we get mesh inlet is 0.0048 meter, and outlet we get 0.0048 meter, same as inlet. After that, the viscosity inlet we get 0.001003 kilogram per meter per second. Outlet we get same as the inlet viscosity. Velocity inlet we get 6 meter per second. That's all for the simulation for L tube. After that, we go to the simulation 3 tube. Okay, density inlet we get 998.2 kilogram per meter. Outlet we get the same as the inlet density. Pressure inlet we get negative 2691.989 Pascal, but pressure outlet we get 0 Pascal. Velocity we can see that 3 meter per second inlet, and the outlet 1.52 meter per second. Next, I want to share about mesh inlet and outlet. Mesh inlet we get 0.00013 meter, same as the outlet, and the viscosity inlet we get 0.001 kilogram per meter per second, same as the outlet. Okay, that's all for me. Thank you.
Assalamualaikum and hi. My name is Muhammad Afiq Haikal bin Mayudin from the class of PMMM session 1/1. My metric number is B092010066, and now I will present about the conclusion of our experiment of pressure in pipe. Based on the experiment and simulation done in this project, we were able to follow the instruction given to conduct this project smoothly. By done the flow exercise in hose pipe experiment, we have recorded the needed data such as time taken for a tank to fill the water for a certain volume. Therefore, the flow rate can be calculated by using all of this formula data. Since there are two figurations of pipe in this experiment, for the straight line water hose experiment, we had recorded that the time taken to fill the tank is 42 ml of water is 34 seconds. Meanwhile, for the second is closed loop water hose experiment, we had recorded that the time taken to fill the tank with 32 ml of water is 28 seconds. From these two data, both of these data, it shows experimentally the flow rate in the straight line hose is greater than flow rate in the closed loop water hose. The velocity of water in the straight line water hose is also greater than the velocity of water in the closed loop water hose. Therefore, the straight line water hose configuration makes the flow of water give the pressure greater than the closed loop water hose configuration. Otherwise, for the second task of our project, which is in the CFD simulations using the ANSYS software, we have obtained the needed data for this experiment. For the first one, we have the inlet pressure shows in the simulation is 35,823.53 Pascal, or if we convert to kilopascal times with 10 power of negative 3, we got 35.824 kilopascal. It means the water flow into the water hose give the pressure of 35.824 kilopascal to the hose wall. When the water flowed out from the water hose, the pressure outlet we obtain from the simulation is 0 Pascal. This is because the water flow out from the water hose, there are no wall and the water is released outside. Then underneath the data, we also obtain from the simulation is the density of water. The density we got from the simulation is 998.2 kg over meter cube. The density of water is same in the outlet and inlet of the hose as in the theoretical value. In the same way, the viscosity of water also same both inlet and outlet accurate to the theoretical value. This is same with the density. Then we obtain the viscosity of water from the simulation is 0.001003 kg over meter second. Then the other data is the Reynolds number we have calculated by using all of the data needed, and the number we got is 110.1208. Since the Reynolds number is less than 2300, so we found that the flow of water is laminar type. The last one that obtained in the simulation is fine mesh of the inlet water hose. We got that based on the simulation, the value of inlet water hose mesh is obtained is 0.004778052 meter. It is so tiny. Hence, the mesh of the water hose is fine. So, based on the result, we can conclude that this experiment is suitable to get and know the pressure of water in the two different configurations as the theoretical value, since the most of the result that we got of this experiment is follow the theory. That's all from me. Thank you.